Today we have Mike Ingeldew, and he is going to be talking to us about the changing role of the technical publication in integrated product support. So Mike, I'm going to hand over to you.
So firstly, thank you for inviting me along or allowing me to speak at the ISTC event. My name is Mike Ingeldew. I know some of you, Terry, Mike, you know who I am already, so you can go grab a coffee or something while I do the boring bit. But my name is Michael Ingeldew, but everyone calls me Mike Ingeldew. My background is actually aircraft engineering. I come from a helicopters background, which you could probably tell by a lot of the stuff that's going on behind me here. And I moved into technical communication actually as a second career when I left the armed forces because I was tired of being ripped apart by helicopter engines and things. So I wanted to stay in engineering, but I wanted to actually, continue to develop some other skills. So I actually went to BAE Systems, worked on the Eurofighter Typhoon project, where I was working on the technical publications there. And then I moved into various roles, and there's a couple of companies you've probably heard of. I ended up at operations manager at a company called Mecon, working for a guy called Julian Murfitt. Left there, started my own company, which was bought by an American company, which was later bought by Boeing. And I ended up working at Boeing Commercial Aircraft, where I was just going around the world advising clients on how to adopt things like standards and specifications and those kind of wonderful things. So I am actually the UK industry rep on the international community for what is known as S1000D, which we will talk about very shortly. So I chair the working group underneath a group called Team Defence Information. And Team Defence Information are all about the UK MOD and how they can exploit and leverage tech data, connected platforms, and how that gives them that extra fight advantage if they ever needed to do it. So my role today, my job today is I've been running Tech Data World now for a very long time. I hated working at Boeing. I don't think there's anybody on here from Boeing. I hated working at Boeing. I don't like working in large companies. Boeing itself was a fantastic company to work for if that's your thing. But it's not my thing, and I like to be in small, nimble companies. So I started Tech Data World with my wife about 10 years ago, and now I just advise clients worldwide on how to adopt standards and specifications, identifying software, implementing process. Just had a question in from India about adopting something called S3000L, which I'll explain shortly. And at the moment, I'm deep in the midst of training the Dutch Ministry of Defence on S1000D based technical publications, as well as S2000M, which is something else that we will come on to. So today, this is going to be a very much a kind of a skirt over a lot of what I've just talked about there, because I could talk about this stuff infinitum, and you don't want me to. So I have had literally 30 minutes ago, I had a network switcher fail on me. So I'm now connected to my router via Wi-Fi, which isn't always the best. So if I vanish, it's not because you're boring me. It's because my hardware has let me down. And I live near a little airfield as well. I live near Goodwood, and today they have decided to start flying the Spitfires around, and they always tend to go off around the top of my house, especially when I'm online and I'm about to give a presentation. So please forgive me. I didn't order them. They are here. And without further ado, we'll get into the technical publications presentation here. So my bag, as I have said, is very much aerospace, defense, and space. I've worked on lots of platforms worldwide, everything from the Galileo ALMA projects, if you're into your space and satellite systems, all the way to Altai Tank over in Turkey. Recently done some training and consulting for Canada, and I'm currently supporting the Australian Department of Defence on their adoption of structured languages. So I'm doing a quite wide array and supporting a wide array of organizations worldwide, which is great because not only do they get to see my beautiful face, I actually get to learn from them, and I get to learn what they're up to and what they want from tech data, and where tech data is going. And I'm talking very specifically tech data here now, because you'll understand why as we move through this. But I'm going to talk about the changing role of the technical publication in aerospace, defense and space. And this little beauty was flying over the back of my house yesterday, so I got a picture of it, and I thought I'm going to show it off because I think it's a fantastic picture. But today's platform is becoming vastly more complex. It's becoming vastly more data integrated. In fact, if anybody is following any of the military news that's out there at the moment, and we've got a new armored vehicle coming into service shortly within the UK MOD called Challenger 3, which is the new main battlefield tank, and that is they're saying data ready, and they are trying to future-proof it, so the next couple of generations of operators and maintainers are going to be able to integrate with external silos and information pools, which we'll talk about shortly, to maximize the longevity of that platform and that product. So they've actually put together a really nice 3D image that I am trying to get permission to use, and I'm just waiting on the MOD getting back to me. But we are now looking at ways that we can integrate our platform directly with the data and the data with the platform. And there's mechanisms for us to do that in aerospace, defense and space. And it's predominantly around standards and specifications. But the way that we communicate today, and I'm not sure anybody would actually recognize the second one in there. In fact, I'll grab it off my shelf. Anybody recognizes that, let me know what they think it is in the chat. But I've just bought one of those for all of you on this call are far too young to know what that is. But the way that we actually communicate today, in fact, I've got my TechDocs red hot phone helpline there, as I call it, with my customers. The way that we communicate today is changing, and it's changing at a rate, and it's changing rapidly. You've only got to look at the way that we were communicating only a couple of years ago, and nestled in the corner behind me here on that shelf is a ruggedized laptop. That's already obsolete. It's only 4 or 5 years old. And the way that we deploy information today and we integrate information today is changing at a rate. Certainly in our domain, in the domain that certainly Terry and I move in, it's a rapidly growing and diverse methodologies for delivering our data and pushing our data and exchanging data with our customers, our suppliers, and obviously our allies as well. So when we talk about the modern technical publication, we're very much talking about things like IETP solutions or integrated electronic technical publications. Now, believe it or not, these things have been around for quite a long time now. But in the aerospace, defense and space sector, some of the projects that I'm supporting, I've just been asked to write a paper for the US Army on structured languages and what they get from structured languages. And this is still quite innovative technology to them. And, I showed an IETP to the Dutch guys a couple of days ago, and they were blown away by it. And I'm thinking, we've been doing this for 10, 15 years now, maybe longer in some areas. And they think that this is quite innovative. But from a maintainer's perspective, they care very much about what's going on the screen. But from a modern information producer's perspective, manufacturer's perspective, a systems integrator perspective, we care very much about what's going on behind the screen. We care about how we are identifying our content, and I'm sure I'm preaching to the converted here, but I'm sure you guys are familiar with structured languages and XML and how and why we use those things. But we break our content down into identifiable pieces of information. Why do we do that? Because then what we can do is we can integrate that into systems. And if we've got a parts system that wants to just go and interrogate our technical publications, for example, for parts information, we can do that. Rolls-Royce Engines does that. They are using the technical publication as a pseudo integrated logistics support database, as they call it. so they can query the technical publications. But there's much more going on in terms of the technical publication can capture information from the end user in real time, or they can capture fault codes from the platform, and we can use information and drive maintenance practices in ways that we were never able to do so before. And you've only got to Google things like Pratt & Whitney, Rolls-Royce, GE. All these guys are looking at how they can really maximize the business advantage, commercial advantage of technical data, of which the technical publication is central. I'd be interested to know if any of you have heard of a term called condition-based maintenance or condition-based maintenance plus. Technical publications in our domain are very much at the heart and the center of that. But when we talk about technical publications in aerospace, defense and space, I'm sure many of you have heard of the specification S1000D. Now, S1000D has been around for a very long time, and it's been around longer than I've been involved in tech pubs, and people still think it's a very innovative way of creating our technical publications. It has upside, it has downside, and there are limitations to everything that we do now. One thing, when I'm talking to my customers, I tell them that we have to stop. I've got an old Morris, 1970s Morris manual here on the side. We have to stop thinking in our domain now. We have to stop thinking a technical publication equals this. It's that on steroids. It's that much more complex and much more sophisticated in the way that we can integrate, that we create it, we can share it, and we can filter it. And you know, we can provide data sets and content to our customers, to our allies, in ways that we were never able to do so in the past. So, but what is S1000D? Well, firstly, it's an international specification for the production of technical publications. And I personally believe it's poorly named, and it should actually be renamed into the International Specification for the Design, Configuration and Engineering of Technical Documentation. Because when I come onto a slide very shortly, you'll see why I mean that. But it's universally accepted as the go-to specification in the aerospace, defense and space sector. Last week, I was answering questions from NASA, and they were asking me questions around how to adopt S1000D in specific environments. There's emerging technologies right now, which I can talk around the periphery on, is Epropulsion. So if we've got battery-powered helicopters, battery-powered ships and drones, and these things are all now looking at adopting S1000D, because in there we have something called a standard numbering system, which gives us a great way to break down those new products, and we can use the SNSs, the standard numbering systems, in our bill of materials, in our engineering designs, and we can map all of this through to our technical documentation. And if anybody is familiar with this, I appreciate I'm leaving lots of gaps. We've got an hour to go through through an international specification. So, and we're building on XML structures. So we're building on a set of agreed schemas that have been internationally agreed, internationally defined by organizations like Boeing and Airbus, and international cooperation with defense organizations, etc. So we have a lot of universal and domain-specific requirements have gone into our development of the specification, the S1000D specification. But now it sits within a series of specifications. So traditionally, S1000D would have been used with integrated logistics support specifications like 1388, if you're familiar with what that is, or 0007, which are logistics environments where before we even get to tech pubs, we have ILS engineers that will go and tell us what we should be putting in our tech pubs. And we would take the data that they create, we would push it into our technical publications, and we would create the world's best technical publications. But now we're sitting within a series of specifications. And we break our content into modular concepts. I should think that's nothing new to you guys on here. And so we're breaking our information down into those what we call data modules. Those of you coming from a data background, you're probably familiar with topics and those kind of things. Essentially, these are the same things, but we can tie information to a platform. We can tie information to a system, a subsystem, or an LRU if we wanted to, a line replaceable unit or a component. And it is supposed to be a neutral method for us to configure our content. Because our platforms are now far more complex than what they were in the past. When I used to fix these Lynx helicopters behind me, they were mechanical, that we kind of, if you pulled a lever, you knew that there was a whole bunch of chain and stuff that was going to move something. Now they're far more sophisticated, fly-by-wire, fuel-by-wire, all of this kind of stuff is something that is far more technologically advanced than when I was training to be an engineer way back in the late 80s and out in the 90s when I was in Germany. And so we have the ability to configure our technical publications. And what that means is that we have, in S1000D, we have something called applicability. And applicability in traditional technical publications, conditional text maybe, and we can go into a technical publication. We can say, I'm working on this serial number in this system with this set of service bulletins, and the content will filter for you, and it will present it at the right time to the right person in a way that is amenable for them to access and use. Now, hopefully this little bit is going to work. So let's talk about S1000D in 60 seconds. And so essentially we're taking our monolithic document, and that monolithic document is broken into modules, and we break out illustrations as well, and we uniquely identify them. And we uniquely identify them and store them in what is known as a common source database. Here we're showing these all listed in what is known as a DMRL, but we need to bring them back together. So we have something called a publication module, maybe a DITA map or something along those lines that you guys are familiar with. And then ultimately, we need to get back out to a technical publication. And on here, I have a whole bunch of IETPs, or we can go out to print, we can go out to mobile apps, we can do whatever we want with this content. So we're breaking down that monolithic silo of information, turning it into topics, turning it into data modules, breaking it down and controlling it in something called a DMRL, which gives us a scope document for our technical publications. And we then create all of that content, we assign it to our technical authors, and they will then write all of that content and we'll publish it out wherever we want it to go. So if I just clear level 3, you should come back up again. Oh, that worked quite well. I'm quite pleased with that. So we have multiple domains that feed into our platform. And you can tell I'm a bit of a helicopter guy, right? So we have multiple domains that feed into our platform. And that means we have multiple silos of information that we have to pull on and draw on when we are creating our technical publication. So something that the defense sector doesn't normally talk about is sales and marketing. Of course, our commercial aerospace guys do. Maybe some of the people that we talk about, tier 1s, tier 2s, and tier 3s, the tier 1s and tier 2s might have a sales and marketing division, legal kind of area. But we have all of these silos of information that pour into our product. But our products are, again, this is the first, you're getting to see this slide for the first time. I created it yesterday. I'm not sure I'm going to like it yet. So, but our products are tech pub supported for generations. The Lynx helicopters came into service in the early 70s. They only went out of service a couple of years ago. In fact, last year, that was the last flight. So that's generations of maintainers. That's generations of updates and maintenance hours around that particular platform. So what does that mean? That means if we have a simple line graph here, our product is designed and it comes into service early doors, and we have a set of technical publications that are supporting or will support this platform. Over time, we will see that there are multiple iterations and changes and modifications to the platform, because a lot of our design assumptions that we make early doors may need to change. And if you look at something like the AWACS platform, if you're familiar with the AWACS platform, the one that's got the big dish on the top as it flies around, it'll be flying around above us somewhere right now and you won't even know about it. That thing came into service in the 70s. It's just been extended another 20, 25 years. This is in the public domain, so I can share this with you. It's going through a black cockpit upgrade. So in the 70s, when it came into service, you can imagine the technology that went into the cockpit. Now that cockpit is being updated with new modern technology, and it's being called, it's either a dark cockpit or a black cockpit, whatever you want to call it. And over time, our technical publications will continue to maintain this product and support the maintenance of this product as it goes through its life cycle. Now, why the gap? Because at some point, of course, the technical publications are only in a maintenance phase. Early doors, we're creating and generating lots of technical publications, but then the product will go off into wherever we want it to go, and the technical publications, I won't say frozen, because they do this. The life cycle of a tech pub is that we, in our domain, we are updating it and changing it through service bulletins, modifications, safety information, product changes like that AWACS platform that I just told you about. We would take all of that technical publications and make sure that it actually resembles the product as is at that point. But at some point, the scope of the technical publications won't change particularly. But this is very linear and doesn't actually really reflect the reality and that sinusoidal kind of wave when it comes to our technical publications production. So what does that mean from a technical publications perspective? I've done lots of sales pitchy there with you. Let's talk about the modern technical publication right now. So the modern S1000D technical publication is engineered. It's not just written. So we have all of these silos and we have all of these requirements that push into our technical publications requirement. And the technical publications team today is much more than a technical writer. And I'll use my words very carefully here because I don't want to upset any technical writer. But the technical writer needs to be familiar with, or the technical publications team needs to be familiar of all of these silos that are coming in. And we'll talk about these silos up here very shortly. But these silos are what we often call data lakes. And these data lakes will feed into lots of configuration control, customer requirements, legacy data, and how we're going to handle legacy data. What's our maintenance philosophy, our training philosophy for this product? And then all of that is going to feed into our technical publications. And what we do is we then, as the technical publications guys and the technical publications engineers, we decide how and where we're going to create this content. And we have to be cognizant of where this is going. We're no longer just publishing to a paper-based manual. We are going out to IETPs. We're going out to maintenance management systems, learning management systems. We're going out to ERP systems. And ERP systems are, the enterprise resource planning, which is including all of the skills, the human resources, any kind of parts ordering, anything along those lines. We can actually integrate and talk to the technical publication. And ultimately, many of us are still translating our content as well. Not so common in the aerospace sector, but certainly in the defense sector. Some of the customers I'm supporting, the product, I nearly said what they're producing, but some of the products that they're producing are translated and they are pushed out the door. So we have to be aware of that. And we have to be cognizant of that. So we have what we call as modern data lakes. So we have the modern platform. And I know this is a 1970s links, but it's just something that I'm emotionally attached to. So and we have all of these data lakes that are happening behind it. Now, this, of course, is a simplification, because invariably, when the UK MOD, who are just about to replace the Pumas with another platform, they don't say we want one helicopter. They want multiple helicopters. And what they then want is they need multiple variants. So if we have multiple variants, so some might be going on the back of a ship, some might be going into sandy climates, some might be working just here in Europe, and some might be going into other places that we may not have even heard of. So we have variant information that we need to be aware of. And those variants have multiple conditions. And those multiple conditions could be different states of modification, or they could have different geolocation information. So how a helicopter operates in the desert, I can tell you through experience, how a helicopter operates in the desert is very different to how it operates at Middle Wallop or in Ipswich or wherever they are when they are just flying around in, let's say, sunny Britain. But we have lots of conditions that we need to be aware of. All of this, the technical publications guys need to be aware of, and our configuration systems need to be aware of. But we also need to be aware of where and how this data is being integrated. Remember, behind this, we're talking XML data. We're talking structured data that we're configuring in accordance with all of these data lakes, and we are going out to lots of different systems, health monitoring systems, maintenance management systems, enterprise resource planning systems. So we have to have now on products that are super complex, have a long life cycle, have complex support documentation requirements, and they're taking data from lots of different domains. And so in our area, we call them domains. Some organizations will call them silos or disciplines, but we're taking this data from lots of other silos or disciplines or domains, whatever you want to call it. So we need to have a methodology for how we're going to have all of these domains talking to each other. How are we going to actually enable something called the digital thread, the digital twin? I'm sure you guys have heard about this, or you're looking at that. Rolls-Royce, Boeing, Airbus, UK MOD, everybody is talking digital thread, everybody is talking digital twin. How can we actually, if there's an aircraft that's actually out on the back of a ship somewhere and it generates a fault, how can we back in a office somewhere load up a digital replication of that that platform? Is replication the word? Replica of that product, and then we can generate the fault and we can see what's happening in that digital twin of that particular piece of equipment, and we can help diagnose the problem. We're seeing lots of things like remote assistance becoming much more prevalent in our domain. So step in something called the S series of specifications. We're going to have a methodology for all of these domains to talk to each other. One is S1000D, of which you are now experts, and you know what S1000D is and how it works and why it works. We have something called S2000M, another baby of mine, which is all about material management. How are we, when a product is in service, how are we going to provision for parts and spares? What's the contracting requirements? What's the pricing methodologies? What's the transportation, storage, security, all of these kind of things. So we have an international specification called S2000M. S3000L for logistics support analysis. You might have heard of 1388, 0007, DEFSTAN 0060, these kind of things if you're familiar with our environment. So this is where your logistics engineers will do their magic. S4000P is preventative maintenance. How are we going to take what we've learned in our modeling and turn it into a preventative maintenance program that will ultimately end up inside our technical publication? And then our technical publication will drive when these tasks and checklists, etc., are carried out. Now we have 5000F. Why is 5000F important? So 5000F is all about in-service feedback, because now we want to make sure that the early assumptions that we made in our product design and we have delivered to the end user were true and correct and accurate. And if they're not, what are the corrective actions we need to take? And how does that influence our product designs of the future? So we can now put the technical publication at the center of feeding back actual metrics from the platform, from the end user, and the number of tasks a time is done, how many spares have been ordered, etc. But we also have 6000T. The technical publication and the training environment are very, very closely related. And you will see now that many, certainly when I first started my engineering training, the training was, there's the technical publication, that's what you're going to learn, and that's what we're going to do for the next 12, 18 months. But now we can still use the technical publication in our training environment. And something I showed the Dutch yesterday was a technical publication that I've created a little augmented reality app. We ran it over the traditional technical publication, and up popped a couple of videos, and they could see from a learning and training perspective, that's something they absolutely need to be doing. So S1000D and 6000T will be talking to each other, and talking to each other very, very closely. And we have something called simplified technical English. And I'm actually not comfortable with the title of this specification, the preparation of technical documentation. I think it's the preparation of the language that's going to be used in the technical documentation, but we can have that philosophical discussion another time. So we have these specifications. Now, when I tell you that that is only the high level, there are what is known as glue specifications that sit between these specifications that enable them to talk to each other. They're called data mapping specifications. S1000D has one called S1000X, which says if you're using these specifications, these are the datas that map to S1000D. Parts information from S2000M is a good example. What are the data elements that we need to use and what we're going to have? So now this one you are completely familiar with, and you understand all the data lakes and the configurations. What does that mean for our technical publications environment in terms of our product support? We now have these specifications that are designed all to talk to each other, and they will all feed in at some level to the technical publication. And that technical publication will manage our fleets of information to support our multiple conditions around our multiple variants around our platform. And we are able then to take feedback from all of these environments. How many times has a particular individual done a task? How many times have we ordered a part? How many times has a particular component failed? And we can feed that back into all of our data lakes, and we can have a look at where our assumptions were good, where they were bad, and we can close the gap and we can close the loop between all of these domains. So the S series of specifications is what we are now calling integrated product support. So right from the design all the way to decommission or death of a product, if you prefer. So how do we actually, from our very early engineering, when we're writing and designing our product and we think we know what it's going to do, to right the way going into our S3000L and our ILS processes and environments, we can push that through into our technical publication, which can glue all of these domains together, and then we can access that information in ways that we were never able to do so. So the technical publication is much more than just a written piece of information on a page or a written piece of information on a screen. So this slide you're familiar with, but now we're going to overlay here the S series of specifications. So you can see that the S series of specifications are now these domains or these silos or these disciplines that we are going to talk to. And through software and through skill, we are going to be taking data sets and databases and mapping data from all of these silos and repurposing them and connecting them in our technical publications environment. For those of you who want a little bit more information about the S series specifications, here you can see the types of data flows that we're talking about. And if I was on a full course, I would be talking about what these dotted lines mean. That's way outside the scope of today, and you'd all fall asleep by the time we got to the end of it. But you can see that these domains, these silos, are all talking to each other. They're going to talk to each other, and we can have that feedback and that continuous improvement loop that's coming through. All ultimately is going to enable things like digital twin, digital thread. So if a component is fitted to an aircraft, or a tank if you prefer, and we can, through serial numbers and all those we can track its entire life, see where it's been, type of maintenance that's been performed to it, and we have a complete audit trail throughout its entire life of what's been happening to a component. If you're interested in adopting these specifications, it's not my job to sell them to you. We have something called SX000I, or some people call it S10000I. I call it SX000I. It's just easier for me. It's a handbook that you can download completely free of charge. It'll give you some more information about all of these specifications. This is not mine, and it is definitely they're free of charge for you to use. Go download it. Terry, you've probably already got it, I would have thought. But at that point, I'm happy to answer questions, but I will just finish off by saying a few final items when I do that. With the ISTC, I've offered to step up an aerospace defense and space focus group where we can share ideas, and I can help educate some of you guys around what's happening on this. I am on YouTube, Twitter, LinkedIn. All you have to do is search Tech Data World in something like on YouTube, and you'll see my ugly mug turn up. I release a video pretty much every Sunday, not all Sundays, but pretty much every Sunday. We have an S1000D for technical authors course running in July. Already a number of authors booked onto that from MBDA Missiles, and Ultra Electronics are joining me on that. We run an IPS event, Integrated Product Support event, every November in Bristol. That attracts a lot of the UK MOD and a lot of the aerospace defense and space community from around the world. We also broadcast that live online. So I know, Terry, you come every year, but if you wanted to just join that online, we broadcast it online as well live. So you can still interact with the event. And that's Ingeldew's email address if you have anything you want to throw my way. I do tend to answer my emails. And at that point, James, I am done.
Well, thank you very much, Mike. There was a lot in there. So we've got the podcast out, and you can find that at the web address on the screen there. And our next month's event is going to be with Björn Smallbro, who's doing designing Adobe FrameMaker templates, and that's going to be on Thursday, the 10th of June.